Hi, thanks for joining our reInvent session on intelligently automating your cloud operations. I'm Tipu, and I've spent the last 10 years guiding customers on how to migrate and operate efficiently in the AWS cloud. With me is Arvind.
Hi, and I'm Arvind Raghunathan. I'm a specialist technical account manager working with enterprise support customers in the operations excellence journey and adoption of operational best practices.
Today, we're going to equip you with the best practices that we've learned from supporting customers over the years. We're going to guide you on how to realize the operational excellence that you can for your environments through automation, using intelligent data sources, and then augmenting these further through machine learning. We're going to give you real-world examples so you can see how this happens in action end to end. Over to you, Arvind.
Thanks, Tipu. Supporting enterprise support customers over the years has provided us the opportunity to work closely in solving their operational challenges using intelligent operations. But first, let's talk about enterprise support. Enterprise support is a 24/7 support across popular channels like phone, chat, email. And you get a technical account manager or a TAM who is an AWS person on your team and the designated point of technical contact. The TAM can enable you with intelligent operations and refine your operations to be more effective. Together, the TAM, along with the access to AWS subject matter experts, we focus to help you achieve your business outcomes and find success in the cloud. We do have one big customer that uses enterprise support. It's Amazon.com Retail. Enterprise support has proactive engagements and tools like workload diagnostics, architecture reviews, operational reviews and deep dives, and tools like personal health dashboard, trusted advisor, APIs for your health and support, which we will unlock during this presentation. In order to get this journey started for our customers, we built AWS Managed Services, or AMS for short. And no matter what standards you use for operations, be it DevOps or ITIL or ISO, AMS supports you, and everything we have done with the service to date has been focused on moving the important but undifferentiated tasks away from the human hands to automation. Both AWS Enterprise Support and AMS works with you to enable, build, and operate on AWS. And within each phase, you go through a journey. For example, enable is all about establishing the foundations with services like Control Tower. Build is all about helping you advance your ability to build code and deploy in an increasingly immutable fashion using services such as Code Deploy, Application Registry, and Operate, where we work with you to help you operate the variety of your applications effectively using services like Systems Manager Ops Center. AMS and support helps with all three phases, and AMS provides a deeper level of operate assistance. This way, your cloud experts can focus on the higher level tasks that matter to your business. Speaking of cloud experts, we give you access to the same cloud experts that we use to build our service directly and indirectly when you're using the AMS service. This allows you to reach into the AMS organization and use AMS as an example of what good looks like as you start to build those centers of cloud competency in-house. We also offer ongoing cost optimization. We continuously and consistently work with you to identify ways to optimize your environment, like right sizing, leveraging auto scaling, leveraging managed services or reserved instances. There's also no vendor lock-in, which refers to the fact that with the exception of endpoint protection, we built our platform readily available with those AWS tools like CloudWatch, CloudTrail, TrustAdvisor, the same tools that is available in a non-AMS managed environment. And finally, contractually, AMS is a month-to-month consumption-based service, so it mirrors what AWS has done with the utility compute model. Let's take a look at operations at scale. What's the problem? What does it mean? For example, in operations, these are some key operational practices even for AWS. Say, for example, in production, you have to provision your environments, your resources through infrastructure as code, define your configuration state and AMIs using SSM. You utilize CI/CD to perform your seamless flow of code to production. You perform blue-green deployments. You also do similar practices in your non-production environments. For example, you perform game days in addition, chaos experiments with different sets of configuration items. You may have other lifecycle environments even besides these, and other practices for different workloads like analytics, HPC, serverless, or different business units having different operational needs. What does all this mean is that you have a variety of important operational tasks being performed at scale. Let's take a look at the scale of operations for Amazon.
Thanks, Arvind. Have any of you ever had to plan for expected or unexpected increases in traffic? It's something that we hear about a lot from enterprise customers. And Amazon.com runs an annual event called Prime Day, where customers take advantage of deals. A lot of increased traffic comes to the website. As these users come in, they need to have a seamless experience, and they need to make sure that we need to make sure that they have great purchase experience. Now, during this event, we see large increases in traffic. That day, we saw 11.1 trillion I/O requests. This meant about 290 million HTTP requests coming in per minute into our CloudFront content distribution network. The amount of resources that had to be scaled up was significant across each one of the stacks. And as you can see, this kind of increase in traffic would require some planning. But this scale meant great opportunities. So as the traffic increases, as we're dealing with large scales of resources, there's a lot of operational efficiencies that can be driven. Unused resources, cost optimization can occur. We can also ensure that there is a smaller blast radius when issues occur. So whenever there is a fault of any kind, that it has very little impact, and that impact is reduced automatically. There's also opportunities for managing schedule changes without interruption, for having a plan ahead of time. And as we're operating at scale, there are performance bottlenecks that we can find out ahead of time and then plan accordingly to ensure that they are optimized upon. Lastly, we can also have the right governance in place for monitoring so that we know what's going on with our environments and we can act accordingly. So as part of enterprise support, we have an infrastructure event management process. And that's what we used for Prime Day. It starts fairly early, right? I mean, for an event like this, planning starts months ahead of time. There are capacity forecasts that need to occur. How much capacity are we going to expect? What's going to be the top line? What's expected? And what sort of buffer we need. After that point, we have to prepare. We have to start creating run books for expected things, for teams to prepare, for us to prepare for unexpected things as well. There's a whole test phase, right? So once we've gotten our capacity, our service quotas, and everything increased, we start testing the system. We run game days to ensure that nothing unexpected can impact the experience of end customers. Now, during the event, or before the event, I should say, scaling occurs. All these resources come up. They need to be monitored for health. There's a lot of eyes looking into what is going on to ensure that end customers have a great experience. And once the event is over, scaling down is also really important, right? Because as part of descaling, you want to ensure that there's no impact to the customers once again, that existing transactions continue to occur. And of course, that unused resources can be deprovisioned so that there's no unexpected costs and that you can optimize upon your costs. So what can really help us to decrease the amount of time it takes to plan, and also just to be able to handle such events again and again at scale, we need some intelligence. That's where intelligent data sources come in. Now, there's several services that AWS offers that gives you insights into what's going on with your environment. These services run across accounts, regions, organizations. I want to give you a couple of examples because the patterns of using these are going to be fairly similar. And the first is AWS Trusted Advisor. Now, Trusted Advisor surfaces best practices across the categories of security, fault tolerance, cost optimization, and others to ensure that you have the operational excellence in place, that you know what the best practices are and that you can implement them. It already supports many services that you're used to using, with more coming, like AWS Well Architected. The way Trusted Advisor works is that it gives these best practices to customers via the console, via API, even through CloudWatch events or EventBridge. There's a rules engine that evaluates the best practices based on the usage of the resources running in your environments. Then it surfaces to customers these checks in terms of how well they're doing. Green means that things are going well. Yellow means that there is an opportunity for improvement. And that red, that there's something that needs more urgent or critical attention, especially if there's a security issue. There's another AWS service called AWS Health. And this tells you about events that are going on with your resources. It gives you transparency into availability, into scheduled events, even into performance. Now, for all of the major AWS services, these events are surfaced to customers, to you, through the API, through EventBridge, and through the console. The console is also known as Personal Health Dashboard. You might have seen this as the bell in your AWS Management Console. Now, as we've heard from customers, the integration with popular tools that you use is important. And so that's why AWS Health integrates with PagerDuty, Splunk, and several other tools that you can use to augment your operations so that when these events occur, they get integrated into your systems so that action can be taken either manually or automatically. And that brings us to automation tools. When we run at large scale, there is a need to automate because we can't be doing every single task manually, especially if it's repetitive, especially if it can be safely automated. And one of the key tools that you can use is Amazon EventBridge. Amazon EventBridge takes the data from these intelligent data sources, like Trusted Advisor, like Health. It evaluates rules that you define, and if the rules are met, it uses targets to implement automation or custom actions. Another tool that really augments AWS Health is AWS Health Aware. This gives you an organization level capability across accounts, across regions, to define rules for notifications, for event management. That really is enterprise class. So this can easily be implemented across accounts and gives you the ability to really customize the way you want to consume events. AWS Systems Manager is a series of capabilities that gives you a lot of insight and capabilities to take action on those insights. Now, once you have intelligent data sources and you can integrate them with EventBridge, as we just shared, these can then target Systems Manager. System Manager gives you capabilities like run command, which can run commands in your operating systems like Windows or Linux. Automation, which can run automation within API, any API or most APIs in AWS. There are documents that actually define runbooks for how to handle certain situations so that you can have custom actions, custom automation take place for each type of event that might be occurring. I want to go deeper into one of the capabilities of Systems Manager, and that is Incident Manager. So when an incident happens, it is important to be ready for it, to have a runbook, to have a plan ahead of time so that you can ensure that customers or end users have minimal impact or no impact. So incident response plans can be created in this tool. It can have a lot of integrations with other capabilities like Ops Center and Ops items so that either manual or automated action can be taken. People can be paged in or engaged, or chat ops can be used when events occur. And lastly, we can learn from each of these incidents so that we review what happened during the incident and then drive improvements in our plan so that the next time we do much better. I talked about some custom actions that you can take around automation. There are all these runbooks that can be created for each type of issue that occurs. However, as we've worked with customers over the years, Premium Support has created these automation documents that we call support automation workflows that really take care of the automation piece for common failure modes. These can be used by customers and is available through Systems Manager so that when an issue occurs, you can already have a pre-prepared and vetted automation run through a series of workflows to solve the problem, or to at least get you as far as it can before you might need further help. As Arvind highlighted, we go through the phases of deploying and operating in AWS. First, we use tools like AWS Code Build, Code Pipeline. Things get deployed. We have our tests embedded during that phase. Then in the monitor part, we use tools like CloudWatch and X-Ray to ensure that things are running well. We ensure that we have the monitoring governance to cover all the items that need monitoring as well. The assess phase highlighted over here is using the intelligent data sources, things like health and things like Trusted Advisor, amongst others, to then help you to realize this vision of operating at scale. And one of the key things there is automation. All of this can be defined as infrastructure as code using CloudFormation, using CDK, so that it's repeatable across regions. And then further drilling down into automation, as I highlighted, we have the intelligent data sources. We are monitoring what's going on in our environments. And then in the automate phase, we can have resolution or decrease manual tasks as much as possible. Systems Manager is a key tool here with its capabilities, its runbooks, and pre-prepared vetted runbooks are available through SAW, which is Support Automated Workflows, so that there is less lifting for you to handle. Okay, let's take a step back. Let's have a quick recap about what we discussed. So, as enterprises, you have to run at scale. To operate at scale, intelligent data sources really help to conquer that complexity as they give you insights into your resources across accounts and regions. And next, we use automation tools to take care of as many of these tasks as we can safely and securely so that we can easily operate at scale, so that we can conquer this problem that we have of so many resources and so many users. But how do we validate operational readiness? Okay, so once we have some monitoring governance, we know what we know. We know the known knowns, but there are also unknown knowns and unknown unknowns. And this is where fault injection simulator comes in, because it allows you to inject chaos into your system, to inject failures in a controlled manner so that you know how your system would respond. These failures then allow you to prepare for handling these situations either through better design or through better incident response plans or through better runbooks. And so these experiments that fault injection simulator allows you to run prepares you for operational excellence. Next, we're going to talk about how to further augment this vision of operating at scale through machine learning. Over to you, Arvind.
Thank you, Tipu. So we're going to extend our capabilities from those intelligent data sources and automation and apply machine learning and take advantage of those capabilities as well while operating at scale. So in order to leverage from the AWS ML stack, clearly there's so much available to our customers in the stack. But from this exhaustive portfolio of services, let's take a look at the top of the stack and consider what is viable to shift the toil of IT ops management to AI ops. So first, let's look at Amazon Forecast. If you're looking to scale operations based on time series data, leveraging that, such as operational metrics, such as web traffic to servers, or business metrics such as sales, profits, and expenses, or resource requirements such as bandwidth needed to meet a specific demand, then Amazon Forecast is a great option, which is built in incorporating the machine learning techniques that Amazon solved for over two decades in retail, supply chain, and server capacity planning. ML algorithms discover and learn patterns in data and construct mathematical models to enable predictions on the future data. The ML lifecycle adds clarity and structure for making ML projects successful. It starts with having a clear idea of the problem and business value to be gained by solving that problem. This is followed by ML problem framing, data processing, model development, deployment, and monitoring. Amazon Forecast takes care of all that heavy lifting. Once you provide your datasets, historical and the causal data, into Amazon S3, Forecast, using its AutoML capabilities, can automatically load and inspect the data, select the right algorithms, train the model, provide accuracy metrics, and generate forecasts. You do not need any machine learning expertise. If you have predictable load changes, you can use predictive scaling policy to proactively increase capacity ahead of upcoming demand and run your EC2 fleet at optimal utilization. Predictive scaling uses machine learning to predict capacity requirements based on historical data from CloudWatch. The machine learning algorithm consumes available historical data, calculates the capacity that best fits the historical load pattern, and then continuously learns as more data comes in to make future forecasts more accurate. To use it, you just create a scaling policy with a pair of metrics and target utilization. And forecast creation starts immediately if there is at least 24 hours of historical data. Predictive scaling finds those patterns in CloudWatch metric data from the previous 14 days to create an hourly forecast for the next 48 hours. The daily data added iteratively becomes part of the prediction. So what does all this mean? So take a look at on-premises. You really are dealing with fixed capacity, so your load requirements doesn't really matter. In the cloud, scaling dynamically, you can respond and look at those areas where your customers could be underserved. In the cloud, you can scale dynamically. So as you can see in the graph, in order to follow along with the load, you can dynamically scale up and reach that peak traffic. And also you can subsequently scale down when you don't need those additional capacity and optimize. But clearly you can see that scaling up is a little behind the traffic, and even scaling down, you have some waste. So what it means is you still have poor customer performance until the scaling catches up, or you are over provisioned and there's some waste and underutilized resources. With respect to predictive scaling, getting that data collected with the patterns of behavior, it gets better and better, and your scaling up follows the load and scaling down also follows very closely, which means you are able to handle your previously underserved customers very well, as well as really optimize your resources and reduce that waste. Amazon CloudWatch Anomaly Detection, it enables developers, operators, systems engineers to automate, accelerate, and improve the detection and alerting of abnormal system and application behavior. CloudWatch Anomaly Detection has its roots in over 12,000 internal models. It'll help you to avoid manual configuration and experimentation, and can be used in conjunction with any standard or custom CloudWatch metric that has a discernible trend or pattern. Anomaly detection analyzes the historical values for the chosen CloudWatch metric and looks for predictable patterns that repeat hourly, daily, weekly, etc. It then creates a best fit model to predict and more cleanly differentiate the normal and problematic behavior. You can also adjust and fine-tune the model as desired. For example, you can exclude deployments or other unusual events from being used for the model training. Or you can even use multiple models for the same CloudWatch metric. Everyone can really use this. DevOps Guru is another great capability. First and foremost, it's a fully managed service that you need to only give guidance about your application boundaries, either at the account level or the resource level. You do not need to require any setting up or training any machine learning models or hardware resources. Once you provide it the necessary application info, it automatically starts monitoring the data and metrics to understand your application behavior. As new resources are added to your application, it automatically detects those changes and starts ingesting data from those new resources. So you do not need to have any additional setup of monitoring and alarms. DevOps Guru reduces your noise and helps focus on those high severity issues with those detailed insights. And those insights include detailed metrics, correlates relevant metric anomalies, changes, and log events triggered by incidents, and provides prescriptive recommendations to provide a quicker mean time to resolve. A great resource for you to get up and running very quickly. Let's bring all this together and in the form of some use cases. So far, we covered data sources such as Trusted Advisor, Health, and how to connect those streams of real-time data from your applications using EventBridge and SNS to trigger actions based on events against those AWS resources and services, such as performing actions on EC2 or utilizing Systems Manager to run an automation runbook. Let's look at some concrete examples in action. Now, you may not think that you would do anything that would ever prompt an AWS abuse incident or an abuse to occur, but when it does, picking it through automation helps you to address it with timely and effective response. We looked at Health earlier, and what you see here is that there is a notification regarding abuse. AWS abuse addresses many different types of potentially abuse activities such as phishing, malware, spam, denial of service, etc. And when that abuse is reported, we alert our customers so that they can take the remediation action that is necessary. Customers like yourself want to build automation for handling those abuse events and the actions to remediate them. Let's look at how to build an automation workflow. From your resources, when denial of service reports are published, using CloudWatch event, you can use those rules to trigger a Lambda function that can selectively notify such sensitive alerts to only those users like your security incident team. Additionally, you can take actions such as isolating the instance to prevent further impact. AWS maintains service quotas, formerly called as service limits, for each account to help guarantee the availability of AWS resources and prevent accidental provisioning of resources more than you need. Some service quotas are raised automatically over time as you use AWS. However, most AWS services require that you request quota increases manually. And operators would truly appreciate avoiding that quota increase that stemmed from that dreaded alarm in the middle of the night. Let's look at how you can effectively predict your capacity needs and proactively manage any increases using time series forecasting. We looked at that earlier using Amazon Forecast. So what you see here is you have those data sets that you can funnel it through Amazon Event Bridge and have a Lambda function that can send that usage as well as the Trusted Advisor limits metric on a daily schedule to Amazon Forecast. And Amazon Forecast can be triggered to generate those weekly forecasts, and using that, you can compare that in a Lambda function against your existing quota and submit a proactive service quota API limit increase. And that helps you to stay ahead of your capacity needs. Now, customers are often challenged with what to monitor or the metrics and defining the key performance indicators as a starting point. You could miss alerts if you're being conservative, or if you're too aggressive, that could result in too many alerts, causing alert fatigue. DevOps Guru continuously ingests and analyzes your resources and applications that run on AWS and provides those operational insights. These insights help you reduce the downtime with relevant information on the impacted resources, related anomalies, and provides those recommendations on how to remediate with contextual data such as logs, relevant events, etc. So in this case, DevOps Guru will generate an insight when it detects an anomalous activity. And also you can choose to send it to an ops item in Systems Manager, which is basically a collection of those work items for those events. And an operator can take action by running a runbook against to remediate that event. Now, in order to be more effective in doing this at scale, you can automate this using SNS and run that SSN automation runbook with a Lambda function and set those CloudWatch alarms. Moreover, you can take this further to set that alarm as a rule in AWS config conformance pack to meet your monitoring governance. The config conformance pack will evaluate those rules and report its compliance status. That is, whether you're compliant or non-compliant against those monitoring standards that you just established. Your rule definition can further also have a remediation association to actually set the alarm if found non-compliant. Such rules can further be leveraged by other services like GuardDuty and Security Hub to validate your overall compliance needs. What we'll see in this example is establishing alert governance by automating responses to insights provided by DevOps Guru. This is the DevOps Guru dashboard that provides the overall system health summary, overview of the stacks that are being monitored, and history of events. Under Insights, you see a list of past events that are closed. Settings control your analysis coverage for the resources, the notification scheme, and integration with Systems Manager Ops Center. Also quickly note that there are no CloudWatch alarms in place and no config rule for any monitoring governance. So we are starting with a clean slate. We will now send traffic which will oversubscribe the backend DynamoDB table, which will induce an anomaly that DevOps Guru detects and will provide its insight within a few minutes. The insight is now generated. Taking a look at the insight, it has 4 parts: the overview, the aggregated metrics, which shows metrics for all the resources that detected anomalies in DynamoDB, Lambda, and API Gateway. The timeline shows that an anomaly for DynamoDB started first, followed by API Gateway and Lambda. The relevant events section lists potential triggers, that is a set of operations carried out on this CloudFormation Stacks resources in this region. And recommendations section, which provides prescribed guidance for mitigating this anomaly. Let us look at the corresponding ops item that is generated. This gives all the details of the insight and the related resources. At this point, an operator can choose to respond by executing a runbook, such as enabling a CloudWatch alarm. However, we want our response to be automated instead, using SNS and Lambda. The Lambda function is triggered when the DevOps Guru insight is generated. And the Lambda automates creation of the CloudWatch alarm. The CloudWatch alarm is now generated, and it also creates the config rule, which is used to establish this as part of the monitoring governance. Config will mark compliance for the associated rule with the CloudWatch alarm in place. In summary, what we saw is taking advantage of DevOps Guru's AI Ops powered insight and an automated response that is suitable to establish alert governance.
Now, I'd like to guide you through the key takeaways that we've discussed so far based on the best practice we've learned from supporting customers that apply directly to your enterprise. So, one of the first ones is being proactive. Being proactive allows you to be ahead of events, plan for them before they occur. That's why it's important to evaluate what's going on in your environment and plan for it ahead of time so that end customers and users don't see impact. There are a few tools that AWS gives to you to help with this. And as part of enterprise support, as I alluded to earlier, with Prime Day, we used infrastructure event management to plan for that large event and ensure that it runs smoothly. Next, the well-architected review makes sure that you are following the best practices through the different pillars in the AWS well-architected framework so that you are using the best AWS best practices to ensure that your resources are running optimally. Then lastly, proactive services. These proactive services are deeper sessions and workshops that go into specific areas of your environment, like containers, so that you know where to optimize and how to optimize in those specific areas. Now, to further capitalize on this mission to be proactive and avoid issues, to have operational excellence, there are some additional tools that we offer. The first is, as part of onboarding, technical account managers guide you in the various parts of your business on how to effectively set up AWS for running operationally well. There are regular reviews. There's usage of the tools that we talked about with intelligent data sources like Trusted Advisor. There's also continuous education, and some credits come through as well as part of enterprise support. Next are the proactive services that we talked about that are specialized deep workshops so that you can fully optimize upon the AWS capabilities that are available. And lastly, architectural guidance. Through well-architected reviews, augmented by solution architects, technical account managers, you can ensure that your design is optimally running so that you have less interruptions when your business is running. You're able to meet your business requirements. It's well performant. It's operating well, and that it's optimized for cost as well. Now, there is some work needed to set up automation. There is some diligence needed to ensure that it works well and that doesn't have unintended consequences. However, AWS Managed Services has a team that has learned a lot of these best practices and implemented them for many customers over the years. So AMS is a good option if you need AWS to take care of the heavy lifting to run your operations so that you can focus on your applications. AMS augments your teams, and with capabilities, a lot of some of the ones that we discussed, like systems manager runbooks, incident response plans, and guarantees, ensures that your business can run with operational excellence. I alluded to this earlier, but with great automation comes great responsibility. And that's why our automation must do exactly what it is intended to do. Nothing more. It needs to do this securely, and it needs to do this safely. The first part is defining context. This means the automation needs to recognize what the resource is and what automation to carry out on that resource. So whether it is tags, resource groups, or whether you're using applications, the automation must be able to glean context into what the resource is intended for. For example, you might not want to stop a production database, right? And at the same time, there might be just some dev resources that are sitting down idle and you do want to stop. And so when these resources get highlighted, the automation should be able to get the context of what that resource is and then take the relevant action on it. Now, you want to also restrict the automation to only the key actions it needs to be able to do. Through IAM policies and other security capabilities, ensure that the automation is restricted based on the principle of least privilege to exactly what it's intended to do, so that there's no unexpected things that the automation does. Next, it is useful to think event-driven and serverless. By event-driven, I mean rather than polling an API all the time, you use services like EventBridge that integrate well with serverless components. An event is pushed to you through services like AWS Health, into EventBridge, and then you can take automation upon it. This is a better design for scalability, especially when you're realizing serverless components like Lambda. Now, to summarize, when you operate at scale, you're able to realize the vision of operational excellence through automation. The more repetitive tasks that are taken away, the more responses that you have pre-planned ahead of time by being proactive, the smoother your operations will run. These automations can be further augmented through machine learning capabilities. Intelligent data sources do part of the work, but as highlighted in the examples, machine learning capabilities like Amazon Forecast, DevOps Guru, really take it a step further by helping you to realize complexity at scale, allow you to conquer that complexity at scale. And then lastly, you're not alone in this journey. We have resources for you to get help and get expert guidance. And we have your back. Thank you for joining our session.